Good day, everyone. This is Group 5 presenting one of the types of polymers. According to the book Chemistry for Engineering Students, polymers are giants among molecules constructed by the sequential stringing together of smaller molecules called monomers. And now, let's proceed to our main content of the video presentation for a specific polymer that is used in electrical engineering. The video will contain the following information. Nylon. Nylon is a synthetic thermoplastic linear polyamide, a large molecule whose components are bound by a particular type of bond. Nylon is used for a variety of applications including clothing, reinforcement in rubber material like car tires, for use as a rope or thread, and for many injection molded parts for vehicles and mechanical equipment. It is exceptionally strong, relatively resistant to abrasion and moisture absorptivity, long-lasting resistant to chemicals, elastic, and easy to wash. Nylon is often used as a substitute for low-strength metals. It is the plastic of choice for components in the engine compartment of vehicles because of its strength, temperature resilience, and chemical compatibility. Nylon can also be combined with a large variety of additives to produce different variants with significantly different material properties. Here is a look at a composite gear made of both nylon and carbon. Nylon is commonly referred to using the chemical designation PA and is most widely available in black, white, and its natural color, off-white or beige. What are the characteristics of nylon? Nylon is the condensation properties of nylon or PA copolymer that is composed of several different monomer types in combination with one another. It can be produced in a variety of ways, typically starting with distillation from crude oil, but it can also be produced from biomass. Nylon is classified as a thermoplastic, or as opposed to a thermoset material, which refer to the way the plastic responds to heat. Thermoplastic materials become liquid at their melting point, a very high 220 degrees Celsius in the case of nylon. One of the useful attributes about thermoplastics is that they can be heated to their melting point, cooled, or reheated again without significant degradation. Instead of burning, thermoplastic like nylon liquefy, which allows them to be easily injection molded and then subsequently recycled. By contrast, thermoset plastics can only be heated once, typically during the injection molding process. The first heating causes thermoset materials to set, similar to a two-part epoxy, resulting in a chemical change that cannot be reversed. If you tried to heat a thermoset plastic to a high temperature a second time, it would burn. This characteristic makes thermoset materials poor candidates for recycling. Uses of the nylon in electrical engineering. Applications where nylon 6 is used include circuit insulation boards and switchgear. Nylon is a strong, stiff engineering plastic with outstanding bearing and wear properties. Nylon is frequently used to replace metal bearings and bushings, often eliminating the need for external lubrication. Other benefits include a reduction in part weight, less operating noise, and decreased wear on matting parts. Molecular formula. Molecular geometry. Nylon is made from two monomers, each containing 6 carbon atoms, so the product is known as nylon 66 on reaction. An OH group is lost from the acid molecule and one hydrogen from the amine molecule, so a molecule of water is eliminated. An amide link is formed between the two monomers. Synthesis, addition, or condensation polymer. Chemically, nylon is a condensation polymer made of repeating units with amide linkage between them. Hence, it is frequently referred to as a polyamide. It was the first synthetic fiber to be made entirely from inorganic ingredients, coal, water, and air. These are formed into two intermediate chemicals, most commonly hexamethylene-diamine and adipic acid, a decarboxylic acid, which are then mixed to polymers. The most common variant is nylon 66, which refers to the fact that both the diamine and the diacid have 6 carbon backbones. The diacid and diamine units alternate in the polymer like proteins. The direction of the amide bone reverses of each bond. Inventors: Wallace Hume Carothers, an American chemist, inventor, and the leader of organic chemistry at DuPont. He was the one who credited with the invention of nylon. DuPont began its research project in 1927. The first example of nylon is nylon 66. It was synthesized using diamines on February 28, 1935 by Wallace Hume Carothers at DuPont's research facility at the DuPont's experimental station. Carothers was a group leader of the DuPont Experimental Station Laboratory near Wilmington, Delaware, where most polymer research was done. Carothers was an organic chemist who, in addition to first developing nylon, also helped lay the groundwork for neoprene. After receiving this, he taught at several universities before he was hired by DuPont to work on fundamental research.